Once we know the value of the axis of symmetry, we can use this information to find the vertex by plugging in the value of the axis of symmetry back into the equation as x and determining the value of y. By looking at the sign of a, the number that's attached to my x squared in my equation in standard form, we can determine if the vertex is a maximum or a minimum. If it is positive and it looks like a regular U, the graph opens up and has a minimum. It has a bottom. If A is negative, it looks like an upside down U, and the graph opens down and it has a maximum, also known as a top. In order for us to find the y-intercept, x must be equal to 0. So everywhere I see an x, I plug in a 0 and then solve for y. Let's try this first example. So, here they're asking us for the axis of symmetry based on the equation. Remembering that the formula is negative b over 2a. I'm going to find my b value as well as my a value. Let's plug them in. Negative something all over 2 times something. So negative 11, 2 times negative 6. That's positive 11 over negative 12, which is negative 11 over 12. Now, my vertex is going to be located at x equals negative 11 over 12. But that doesn't necessarily mean that I know whether or not it's a minimum or a maximum. Let's look at the a value. It's negative, so that means this is going to be an upside down U that will open downwards and have a top, so it's a maximum. How do I figure out that y value? Because I already have half of it, I just don't know what the y is. Well, I take that x value and plug it back in. So let's do that. Y equals negative 6, negative 11 over 12 squared minus 11 times negative 11 over 12 minus 4. This is a lot going on. So I'm just going to go ahead and graph this. I'm going to plug this into my calculator and I'm going to use that to get my answer. So first thing, I'm going to call this function f1 of x, close parentheses, equals, and let me go ahead and type in my equation. Negative 6x squared minus 11x minus 4. Negative 6x squared minus 11x minus 4. Okay, so now I want to know exactly where that point is. I already calculated where my axis of symmetry is. So I can actually ask my calculator, hey, if I plug in an x value of negative 11 over 12 into this equation, what would that y value be? And it looks like it's approximately 1.04. My y-intercept is where all my x's equals 0. So I'm going to say y equals negative 6 times 0 squared minus 11 times 0 minus 4. That cancels, that cancels. Y equals negative 4, so my y-intercept is located at 0, negative 4. Let's verify this in the calculator. Let's zoom in, and it looks like I do have a y-intercept right there at 0, negative 4. Now let's go ahead and solve for those x-intercepts. Now, this one looks like it's going to be really crazy because these numbers are really ugly. So I would use my quadratic formula for this. So I would say negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And let me simplify. 11 plus or minus square root of 121 minus 96, all divided by negative 12. 11 plus or minus 25, all divided by negative 12. The square root of 25 is 5. 11 plus or minus 5 over negative 12. Let's split. 11 plus 5 over negative 12. 11 minus 5 over negative 12. And these guys would simplify down to 16 over negative 12, which is about 8, negative 8 over 6, negative 4 over 3, so negative 1.33, 6 over negative 12, that'd be negative 0.5. So let me verify those. So this would be negative 4/3, 0, and negative 1/2, 0. Let's look. Negative 1.33, negative 0.5. Exactly what I was looking for. Now, as a bonus, because I use this, I should be able to look at my numbers here and figure out what the factor should have came out to. It looks like if I work backwards, opposite divided by coefficient. Opposite divided by coefficient. And let's multiply that out to see what happens. 6x squared plus 3x plus 8x plus 4. Six x squared plus 11x plus 4. And guess what? Even though these are all positive, if I multiply it times negative 1, because they're equal to 0, I would get the exact same answer. So I can circle back around.